Greetings to respected Madam Sirs. Today I'll be presenting on the topic 100 lockers problem. So throughout this problem, we will explore key logics, reasoning, and the techniques and the methods that are vital for the effects problem solving in both academics and real-world context. Essentials of problem solving, exploiting the 100 problems, 100 lockers problem and its applications. So this presentation reveals its famous 100 lockers problem. It highlights the importance of developing systematic things like logic analysis and the ability to recognize patterns, all which are essential skills in problem solving. We will examine the problems, exploring its solution methods, and discuss its relevance in real world applications. Problem overview. So, the introduction of the 100 locker problems. So, basically, the 100 locker problems is described as following, like these are 100 lockers which are all initially locked or closed. 100 students sequentially interact with the lockers, and the first student opens all the locks. The second student toggles every second locks, closes the lockers like 2, 4, 6, etc. The third student toggles every third lock, so on until the 100th student who toggles the 100th lockers. The main goal is to determine which locker remains open after all students have taken their turn. And the importance of problem solving. So, solving this problem empathize the critical thinking skills, logical reasoning, understanding causes and efficient across multiple steps. Pattern recognition, observing how lockers are toggling multiple times based on the divisibility. Symmetric, thinking approach of the problem methodology without missing details. These skills are not only important in mathematics, but these are also highly valuable in professional fields such as engineering, computer science, and management. Real world applications. Uh, there are 100 locker problems which have served as metaphors for various real world systems. It helps understanding patterns in decision making process such as voting system or automated workflow. It teaches resource optimization where toggles can represent the actions like switching on or switching off the machine in the manufacturing. It can control systems where certain conditions causes changes in state which are useful in industries like automobile and IT systems. Solution approach. So the step-by-step breakdown on the solution. The key is to solve the problem lies in the recognition, the connecting between lockers and the divisors. Each locker is toggled, each one for every divisor it has. For example, locker number 12, it toggles by student 1 and 2, 3 and 4, 6 and the 12. Locker can remain open if it toggles an odd number of times. Only perfect squares has odd numbers of divisors. Example 1, 4, 9, 16, etc. Thus the logic numbers 1, 4, 9, 16, 25 and so on up to 100 will remain open. Logical reasoning behind the solution. The logic behind the solution is based on the mathematical behavior on divisions. Typically, divisors come in pairs. For example, 2 and 6 are a pair for 12. Non-square numbers has even numbers of divisors because divisors are paired. Perfectly squared, however, have one unpaired middle divisor like 6 for 36, which leads to an odd total number of divisors. Therefore, not only logs are perfect squared positions stays open after all toggle operations. Methods using programming. So, to stimulate methods of 100 locker problems programmably, uh, we can represent the lock as an array of 100 elements which each of them initially set to close example 0. Loop through each student toggling the lockers according to the student number, each and every first and every second, etc. Or after all students have passed, print the lockers that remained open. This approaches the ensures systematic checkup and can easily be extended to more lockers such as 1000 or 10,000, making it useful for testing algorithms at a scale. Common pitfall of the solutions which are misunderstanding the toggle rules, assuming the lockers are only toggled ones, forget all the connections between divisibility and toggling, overlooking and the specific property of perfect square. To overcome the pitfall, a clear and systematic walkthrough must be done, visualizing the toggle process using a simple programming simulation which can help in confirming the logic. While the 100 locker problems appear straightforward after understanding the solution, there are several common pitfalls that can cause confusion, especially when attempting the problem for the first time. First, mainly learners misunderstand the toggling process itself. This might think that each locker is toggled once only by the student whose number matches the locker number. In reality, each student toggles multiple locks. Specifically, the locks are they are multiples of of the student numbers. Second, some may overlook the relationship between divisibility and the other number of times a toggle lock is toggled. Since locks are toggled for every divisors they have, it's becoming a critical to understand the lockers with many divisors are toggled most frequently. Third, an important but often missed insight in recognition that perfect square behave differently because of their unpaired divisors. For example, the numbers which are 3 has divisor of 1 and 3 and 9. The divisor 3 the divisor 3 pairs with itself, resulting in odd numbers of divisors overall. To address these pitfalls, several strategies can be applied. Systematic verification: instead of trying to mentally visualizing the entire process, step-by-step verification for a small number of lockers, say 10 lockers, can be done manually to observe the pattern clearly. Visualization techniques using physical properties such as coins, head or open tails for the closed, or drawing locker state on a paper after each student turns help reinforcement understanding. So the programming simulation implementation is small code snipped to stimulate toggling process not only by saving time but also building a strong particular grasp for problem solving. These methods are ensure the logical mistakes which are minimized and a deeper appreciation of the development. Conclusion. In the speech, in the conclusion, the 100 blockers problems is a class example that showcase the essential principle of mathematical logic and problem solving. The first glance, the problem may seem purely numerical, but at closer analysis, it reveals the important insights into patterns, symmetric thinking, and the nature of divisibility. This problem teaches the symmetric and methodical approach can be simplified the seemingly complication problems, recognizing hidden patterns like the special nature of perfect squares. It crucially solves the problem effectively, and logical reasoning is just as important as calculation. Solving complex challenges often depends more on recognizing structures that are performing heavy computation. Furthermore, the skill practices through the problems have direct real world applications, whether the software engineer for optimizing algorithms, it optimizes research for resource managers, or in electronics for the state transitions in the circuit. Similar thinking process are vital. Therefore, the problems like these not only improve academics understanding, also prepare students who are professional to approach real world challenges with the logic, precision, and the confidence. Thank you.